Welcome to IoT Real Talk. No fluff, no filler, just real pros talking about real programs, real challenges, and real results. Can your IoT devices think for themselves? They might sooner than you think. That's thanks to the artificial intelligence of things. AIoT is reshaping the edge. Think smarter decisions, better privacy, and lower costs. While the promise is big, the execution is still a work in progress. And to separate the signal from the noise, we are joined by Jim Morrish, founding partner at Transforma Insights and a leading authority on IoT trends. In this episode of IoT Real Talk, Jim breaks down why AIoT is more than just AI applied to IoT data, the surprising pace of hardware innovation at the edge, and what is missing from today's platforms and who might fix it. Stay tuned for the latest on AIoT. Hi there, I'm your co-host, Susanna Song, Chief Marketing Officer at Eris. And this topic is fascinating because AIoT, which is, again, the convergence of AI and IoT, may not be exactly what you think. So let's get right to our guest. Welcome, Jim. Great to have you.
Hey, Susanna. It's great to be on. Thank you for having me.
Yeah, and I hear the accent. And for people who don't know you, tell us where you're located and more about yourself.
I'm in the UK, so I'm the other side of the pond from you.
And how did you dabble into AIoT? I know Transforma Insights, you guys really have the pulse on the IoT industry, but what specifically about AIoT got you like researching and learning more about this solution, this new solution?
Well, AIoT is very much a natural extension of IoT, and I should spin back a little there just to frame AIoT as we view it, because you mentioned in the introduction there's artificial intelligence of things, and that actually came after the letters AIoT, and they came about, I think, because having AI and IoT as the two emerging and dominant technologies at the time, it was just too tempting to mash those two acronyms together, and hence AIoT. So it's kind of a general term. It's applied to multiple contexts to represent kind of a range of new technologies with connected devices and imply intelligence to them. However, there is a pure definition of it, and that pure definition is AI deployed onboard IoT devices, and that frankly puts it right in our ballpark, because that's exactly the area we focus on, having focused on IoT for many years now, significantly more than a decade. This is a natural enhancement, and it's quite an interesting market.
Mm-hmm. Yeah, and I think when I first thought of AIoT, and I'd hear that initialism out there, I just assumed it was AI, using AI to analyze IoT. You know, now it's like everybody says, I am AI powered, or I am AI driven, AI enabled, but this is really, exactly, like you said, AI embedded or truly onboarded a device. So how does that happen? And talk a little bit about some use cases so that we can just help our audience understand what that really means.
Okay. So, well, I'll start off with a use case that people are probably quite familiar with, autonomous vehicles, or vehicles with some level of autonomy in them. Those have AI on board. That is, and those are AI algorithms which are frequently updated. They're on board the device, and frankly, you need to maintain a very clean software environment to deploy those those AI models into. Look at something very similar to a connected car. A robot lawnmower, which is cellular connected. There's not a lot of difference between an autonomous robotic lawnmower that's cellular connected and a vehicle, frankly. So there's a lot of these things around, and it's not just autonomous systems. So another example, which is quite an example I quite like, is you'll probably be familiar with these parking monitoring systems, which have a sensor under each space or over each space, and they know when there's a car in that space, and it's relayed to various information locations to tell people where spaces are available, and so on. So obviously there's a fair amount of deployment and installation with that solution. An alternative is just to point a CCTV camera over the parking lot and put an AI algorithm on board the CCTV camera, which detects whether there's a car in space. And that's one device which you deploy to cover an entire parking lot. So considerably cheaper, much less deployment costs, and easier to maintain.
Yeah. Well, you named some of the benefits, but as businesses try to be more efficient, talk a little bit more about really the benefits of running AI at the
Yeah.
source directly on the
Yeah,
device.
definitely. There are a lot of benefits. So, firstly, application performance. You can get a lot more application performance out of applications when you're processing at the edge, because you don't need to scoot data to the cloud. Imagine a self-driving vehicle with the analysis happening in the cloud. It just doesn't work. The lags are too big. And that effect plays across all sorts of IoT and AIoT applications. You can incorporate more data inputs, more granular data inputs, because you don't have to figure out how to get them off the device and into the cloud. You're doing more of the processing locally. And you can increase the resiliency, the uptime of the application. If the wide area connection goes down, your AI doesn't fail with it. It's because it's on board. There are benefits in terms of compliance, privacy, and security. So consider something like a smart speaker. If you use your voice to convey a command to a smart speaker, and that then streams the audio out to a cloud platform, you might regard that as an intrusion on your privacy. However, if you issue an instruction to the speaker and it's processed locally, and then the abstracted text and the core of that request is sent to the cloud to trigger a search for information and send that information back, you've got significantly enhanced privacy. And the echoes of that in an enterprise context where you're getting more, there's more security because content and information is not sent off-site and can be kept locally. And also it's easier to ensure security and compliance, etc. Lastly, reduced operational costs. I've mentioned there in these benefits a few times about the lack of need to send information off board, and that means that bandwidth costs are less. Another example I'll give you, one of my favorite examples actually, is a CCTV camera which is connected via LoRaWAN, which is extremely low bandwidth capability. Technology designed for IoT, and it is a camera, and it's focused on a pickleball court in the town of Cary in the US, and all it does is sense whether the pickleball court is in use or not, and it sends out a binary yes or no, and that kind of traffic can be carried over a LoRa connection, and the alternative of streaming that video to a remote server or processing it in the cloud is just far more overhead than is necessary.
Yeah. Absolutely. And just even having that camera there to that prevents a body count, like another person watching and having to report back to the pickleball owners that it's being used or not. Right.
Exactly. And there's two effects in there, really. So that reduction of the bandwidth and reducing the cost of the deployment means that these solutions can be deployed in many more situations which previously might not have costed in. So, for instance, security cameras in very remote locations, which you might have to connect via satellite. If you're streaming video, that's not practical. If you're streaming some abstracted information that you're specifically looking for, suddenly that becomes a viable solution.
The last research that I saw around AIoT, it stated that the AIoT devices are set to grow to 9.1 billion devices globally by 2033.
Yep.
And that they're saying is almost a quarter of all IoT devices.
Yep.
So what does that tell you? Is it surprising, the pace of hardware innovation at the edge? Or would you think that it should be higher?
Well, first thing it tells me is that you've been reading our research. Because that's where that number came from.
Transforma Insights, yes.
And to some, yes and no, it is surprising. So it's roughly 25% of all IoT devices end up connected. Really, the problem with looking at very high-level numbers, though, is they get distorted by consumer markets. And this has been an issue with IoT since the beginning. The reality is that there are just many more people and households than there are farms and agriculture locations, that you're always going to get more connected televisions and smart speakers and smart watches than you are agricultural machinery. So those numbers, you get very high numbers of fairly simplistic or fairly simple run-of-the-mill consumer type devices, and you got a lower number of really quite sophisticated devices in the enterprise context. So yes, 25%. It seems like a lot is dominated by consumer. That it's faster adopting in the consumer space because there are more homogeneous solutions. But as I say, the really interesting stuff and the innovative stuff is happening in the enterprise space.
Yeah, can you shed light, if you're able to, around some use cases that are maybe not as obvious opportunities that you think will have greater adoption by the enterprise in the future?
Well, absolutely. I mean, so agriculture came up there. How's about things like using drones to spray crops? And do that autonomously. So as opposed to having a boom on a machine which drives up and down a field, you can send these so a drone across a crypt with a spray just to spray the exact places within the field or areas of a plant that need either an infection or some kind of parasite dealing with. So significantly reduce use of chemicals. Much quicker, much lower manpower required, and that's just one example. There are many and varied.
So we have robust IoT platforms today. There are AI software platforms coming out and doing really well today. What's missing from today's AIoT platforms, and who might fix it?
Yes, this is an interesting space, and the concept of AIoT platform is kind of vacant in the market at the moment. What we've got is a relatively well-established series of platforms to support IoT. And we've got fast evolving platforms to support AI. What we don't have are the platforms that combine those two capabilities. So if we just spin back a bit and look at that, two different technologies. They're both very complex. They have very different dynamics and complexities. AI is all about agile iteration of algorithms, continual fast refresh of those algorithms on remote devices, very close monitoring of performance of the devices to monitor for drift and biases that are keeping in and effectiveness that's dropping off. Meanwhile, IoT environments are characterized by remote devices. They are often resource constrained. They often have limited connectivity capabilities. They could potentially be battery powered. And these are just two different worlds. It's very difficult to extremely closely monitor an AI application on an IoT device. Think back to that LoRa connected CCTV that I mentioned earlier. It's great for relaying the message whether the pickleball court's in use or not. But how do you actually interrogate that model and check that it's working properly remotely? It's pretty challenging. And there's a series of challenges which kind of drop out from those just the two different ways those different technologies work. And they fall into a few buckets. So the first one is about compressing AI models so that they can be deployed onto an AIoT device. So you can't put a full ChatGPT 4.0 large language model on a battery powered sensor which is deployed remotely. It just won't fit. So somehow you have to hack it back. There's different ways of doing that, of compressing it down. You need to think through the updating of the software on the remote devices to make sure that they're retrained, refined over time, and constantly updated. You've got to manage the performance that IoT and the AIoT in the field. So drift in models in terms of the input drift, output drift, concept drift, things that are changing. So for instance, you might have a model which is ideally trained to monitor for potential threats in an airport, and it's working very well in summer, but in winter people come in with big coats, and suddenly your model might not be working so well. So you need to monitor for these kind of things, and that highlights another situation, because you might have that people monitoring security solution in an airport, you could deploy the same solution in a concert stadium or a sports stadium. And in those situations, people carrying big bags have a very different risk profile to people carrying big bags in an airport. So there's a lot of differences just in terms of the context, otherwise seemingly similar models that deployed into, and supporting that feedback loop, how lessons from one device or one context can be spread across the rest of it estate, potentially with different clients, different situations, different countries even. And this whole thing, I think as I mentioned earlier, sits on a much greater need for hygiene and just having very tight control of what's happening on the platform and the software environment and the hardware environment that you're deploying the AI onto. Just so you can monitor if performance is drifting in certain subsets. Potentially it's a subset that was fitted with a certain batch of batteries. You need to be able to identify that. And a lot of these things are new problems for AI in an IoT environment, and for the IoT folks, they haven't really thought through these implications of deploying AI into the space. So there's a big opportunity in there, I think.
Yeah. So what is it really like? Just numbers that you can count on your hands in terms of AIoT platforms out there today that are in market, or are we talking about just how far are we in terms of developing robust platforms for AIoT?
I am not aware of anybody that does it end to end. There's a range of people that do different aspects of it, but I'm not aware of anyone that's pulled it together into an end-to-end solution.
So it's still very nascent.
Absolutely. But there are people who do different niches and different elements of it. It's just not quite come together yet.
It's definitely an opportunity.
Absolutely.
Switching gears slightly to security, and you brought up the use case and benefits of cybersecurity for a business. But when we come to talking about just the risk factor for the AIoT devices, we know that the interconnected nature of AIoT systems means if one device is breached, it can impact the entire ecosystem. So my question to you is, and tell me if it's a fair question. With AIoT, is it less prone to a cyber attack, or
it's an unfair question, Suzanne, but that's okay.
Yeah.
So there's two ways to look at this question. One's theory and one's reality. If you look at it in theory, then those AIoT devices have more complex software on them. Almost by definition, they receive over-the-air updates, and that opens a whole new set of security risks. So there is more opportunities to attack these devices than there are with traditional IoT devices. So theoretically, you'd expect probably higher risk. However, the reality is that to manage AIoT devices effectively, as I mentioned earlier, you need to really understand what the physical condition is, whether it's been tampered with, whether the hardware's drifting from the performance it should be, whether it's got the right software on board, the fact that all the software's up to date. Because you have to be on top of that in a way that potentially you didn't need to be in the days of IoT, actually, I suspect it probably ends up more secure.
Okay. That is interesting. Have you done any reports on this aspect at all? Or is that something that you guys are exploring?
We haven't looked at security of AIoT, but it is something that we will be coming to, and particularly, but both AIoT, but also looking at how connectivity management is evolving, particularly from the historic focus on cellular connections, away to multiple technologies and rendering those multiple technologies into a single pane of glass. That starts to get quite close to the kind of capabilities that are needed to start managing AIoT solutions across multiple different technology types. So we are looking into that space at the moment.
All right. Well, looking forward to reading that when it's out. Any last thoughts, Jim, as we wrap up here around your research. Any questions that I didn't ask that you would like to shed light on around AIoT and this phenomenon around it?
Yeah, there is one other area I'd like to highlight, actually, and that's the pace of innovation in the space. So we're familiar with, everyone, I guess, listening in will have heard about the amount of investment which is going into AI, and that is very much dominated by cloud capabilities and AI supporting the enterprise and end users. In the AIoT space, because of some of the constraints that we've discussed during this conversation in terms of limited access to power, limited access to both electrical power and processing power, and so on, and those kind of limitations, there's actually quite a lot of innovation in the hardware space, and folks are developing systems on chip which are optimized for AI image analytics. And then on top of that, they're developing platforms to help build the applications which can be deployed onto devices which house those chips, as a way to accelerate that particular market. So what you're getting is quite a lot of specialization and fragmentation in the hardware space, and very creative ways of really compressing models down to be really ultra compressed and deployed into these locations. So there's more innovation than you might probably expect in the AIoT space. It's considerably more fragmented and diverse than the cloud AI space.
Mm-hmm. So the chip manufacturers, would you guess then they're all at least thinking about how they're going to innovate in this next iteration of AIoT?
Many are.
Mm-hmm.
However, for the bigger ones, the ones that have a foothold in the AI in a data center space, the revenues coming through that channel are just so overwhelming compared to the revenue opportunity for AIoT. So they're kind of distracted into that cloud space, which again opens up the AIoT space to more innovative startups. And there's lots of smaller companies. The big ones are in there as well. So NVIDIA has a Jetstream proposition, etc. But it's kind of a secondary focus. There's quite a lot of small niche companies get an opportunity to say, this is an opportunity, and focus on that opportunity. And those kind of opportunities don't exist in the same way in the cloud space. So as I say, it's another dimension of fragmentation, and it's an interesting space.
Yeah, absolutely. Well, thank you so much to our guest, Jim Morrish. And thank you to our listeners for tuning in. If you have feedback about today's podcast or questions for myself or the AIRS team, even if you have a question for Jim, we'd love to pass it on. Please contact us at podcast@airs.com or leave a comment. We would love to hear from you. Until next time, I'm Susanna Song, and you're listening to IoT Real Talk. From all of us at AIRS, thank you for listening to IoT Real Talk. We hope you'll join us again for more real stories from real practitioners shaping the future of IoT. Tune in on Apple Podcasts, Spotify, or YouTube, or visit airs.com/IoT podcast.